Welcome to today's training session. In this lesson, we will focus on geometry selection and how it affects the accuracy and efficiency of your modeling process. You will learn practical techniques such as using box selection, switching display modes, and applying move and copy commands. The goal of this session is to strengthen your skills through practice and repetition so that you can confidently select and manipulate geometries in your projects. Today we are going to talk about the move command in SpaceClaim software. For this purpose, we first need to draw a 3D shape. I will draw a square, and I want the center of the square to be exactly at the origin point. So for this purpose, I use the equal length constraint command to make sure that the origin is at an equal distance from all sides of the square. Then, I use the pull command to convert the shape into a 3D cube. Now, by using the commands we learned earlier, I apply some modifications to this 3D object. These modifications include drawing another rectangular shape on one of the cube's surfaces, and then changing the 3D geometry, as you can see in the image. Before moving on to our main command, which is move, it is very important to mention a few essential points, such as the method of selecting geometry, which is highly important and practical. In the move command, you can move an object, a surface, an edge, and even a point. Therefore, choosing each of them correctly is crucial. With 3 clicks, you can select a body, and with a single click on a surface, an edge, or a point, you can select each of them. A very useful option in the Select tab is the Using Box option. By choosing this option and dragging a selection box around a geometry, you can select all the geometries within that area, which may include surfaces, edges, and even bodies. For example, by selecting the entire box that encloses this cube, I select this body. After selecting the Move command, the first option we encounter is choosing a surface, a solid, a line, or a point. Here, I first select a face from the geometry and move it with the specified available direction. As you can see, it is not possible to move this surface upward, and this is due to the limitations of the way the geometry was created. However, the other adjacent surface can be moved upward or downward by using this command and selecting the plane. This time, I select an edge of the geometry and move it in different directions. As you can see, this time I select a point and move it. Finally, it is time to select a body and use the Move command to either translate it in different directions or rotate it. After activating the Move command, another useful feature becomes available, which is Select Component. This option allows us to select a body with a simple click. The software automatically recognizes and considers the entire body as a single unit, so there is no need to use a select box or a triple click. The Fulcrum option allows you to define a temporary pivot or reference point around which the selected body or geometry can be rotated or moved. By setting a fulcrum, you gain more control over the transformation, especially when you want to rotate around a custom point rather than the default center. Next, in order to demonstrate the features of the Move tool more clearly, I will draw several circles and rectangles. After extruding them into 3D shapes, I will use the Pull command to show you the different capabilities this tool offers. First, as we mentioned earlier, by choosing the Select Component option and selecting a body, we can move it in different directions or rotate it. As you can see here, this is one of the most basic and fundamental capabilities of the Move command. SpaceClaim also provides more advanced and versatile options for the Move command. One of these is Move Radially About Axis. As you can see, this command allows the selected bodies to be moved relative to a defined axis. After I selected the axis, since I want to select multiple geometries consisting of 4 cylinders, by holding down the Control key on the keyboard, I select all 4 cylinders. Another feature of the Move command is the Up To option. By selecting this option, the geometry is automatically moved up to the chosen point or face. As shown here, I select one cube and then pick a face of another cube to move my geometry exactly up to that plane. It is important to note that by default, the reference point of the Move tool is located at the center of the geometry. Therefore, when moving a body using the Up To option, the center of the geometry is aligned with the selected face. The question, however, is how can we move the geometry so that their faces become tangent or perfectly aligned with each other? Moving the reference point from the geometry's center to its side face, it is not possible to reposition the body without altering its dimensions and attach it to the adjacent geometry. This is because, in this case, what actually moves is the side face of the cube. The solution to this issue is using the Anchor option. This allows you to set the reference point at the desired location so the geometry can be moved without altering its dimensions. For better understanding, I will demonstrate this command on another cube. As you can see, I first select the cube using the Select Component option. Then, I apply the Anchor command And finally, use the Up to option to place the defined point exactly on the side face of another cube. In this way, the selected cube is moved precisely up to the chosen point. Another very important and practical feature of SpaceClaim within the Move command is the Move Along Trajectory option. This feature allows you to move your 3D object along a defined curved path. In this example, by enabling this option and selecting the curve, I move the geometry along the chosen trajectory. In the example you saw, due to the large distance between the cylinder and the curved path, the geometry was moving along the path, but from a distance. To make the geometry precisely follow the selected path, we first use the Up to command, as learned earlier, to place the object at the starting point of the trajectory. Then, we activate the Move Along Trajectory command, allowing the geometry to move exactly along the chosen curve. However, as you observed, this movement was again unsuccessful because, as mentioned earlier, our reference point was still located at the center of the 3D geometry. To resolve this issue, we use the Anchor command to shift the reference point from the center of the cylinder to its bottom face. Then, by applying the Up to option, we align the bottom of the cylinder precisely with the starting point of the curved path. Now that the preparatory steps are completed, it is time to use the Move Along Trajectory command to move the geometry precisely along the curved path, just as we intended from the beginning. When you select the desired body for movement, by clicking on one of the directions, the ruler option becomes active. With this tool, you can measure the distance between the selected body and the adjacent body, and even modify this distance if needed. I also repeat the same operation with these two cubes and the cube on the opposite side, and then adjust the distance between these two cubes and the adjacent cube. One of the most practical and important features in the Move panel is that in addition to moving the selected geometry, you can hold down the Control key on your keyboard and choose a direction to move. This creates a copy of the geometry and moves it while the original geometry remains in place. As you can see in the image, I select the 4 drawn cubes using the Using Box option from the Select Body tab. Then, by holding down the Control key and applying the Move command, I create a copy of these 4 geometries and move them, while the original ones remain in their place. The Move Direction option works similarly to Move Along Trajectory, moving the geometry along the defined direction. In this example, I have drawn a diagonal line and selected it as the direction for moving my cube. As you can see, the cube moves precisely along the diagonal line, following its path. Now, similar to the previous examples I explained, I align the movement direction of the cube exactly along the drawn diagonal line. First, I use the Anchor command to place the reference point on the bottom edge of the cube. Then, using the Up to option, I move the cube to the starting point of the diagonal line and place it there. At this stage, by activating the Move Directional option, you can see that our object moves precisely along the diagonal line and fully aligned with it, exactly in the way we want. As mentioned at the beginning of the session, the Select option and the way you use it properly is very important and can significantly affect your work. In this geometry, I will demonstrate the importance of correct selection. As you can see, in such a geometry, selecting the top cylinder is very easy. and you can simply move it in any desired direction. However, keep in mind that selecting geometry is not always this straightforward, and in many cases it can be challenging. In this example, you will see a practical demonstration of this fact. The holes located in the corners of this geometry are a clear example of such challenges in selection. By switching the display mode to wireframe, we can observe the relative complexity of these holes and realize how selecting them directly can be quite challenging. As you have learned so far, directly selecting such geometries may be difficult. In this case, the Using Box option becomes very practical and useful. By creating a selection box around these holes, the geometries contained within that area will be selected, allowing us to easily perform the desired operations on them. Now that we have successfully selected these holes, in the next step, we can use the Move option to reposition them in various directions as desired on this geometry. Alternatively, in addition to moving the holes, as we learned earlier, you can also hold down the Control key on the keyboard to create a copy of them, and then move the copied geometry. This method is very practical in many cases, as it not only saves time, but also allows you to easily generate repetitive geometries whenever needed. As you have noticed so far, by practicing and repeating the commands taught in this session, as well as reviewing those from previous sessions, our main goal is to help strengthen your learning. With more repetition and practice, you will be able to understand these tools and commands more effectively and make better use of them in your projects. I hope this video was useful for you. To benefit from Mr. CFD's services, including simulation, consultation, and training, visit our website and contact us via these addresses.